Now let's get started. My name is Leah from Painless Math, and I will be your tutor. Today's theme is prime numbers and prime factoring. First, let's start with prime numbers. Prime numbers are numbers that have only two factors or divisors, which are one in themselves. What this means is that, for example, 2 can be divided only by 1 and 2. That means that 2 has only 1 and 2 itself as its divisors or factors. Therefore, we can say that 2 is a prime number. By the way, when we say a divisor or a factor, we refer to a number that can fully divide a certain number. Then how about 3? 3 is divisible only by 1 and 3 itself. So 3 is also a prime number. How about 4? 4 can be divided by 1 and 4, but also can be divided by 2. Therefore, 4 is not a prime number because it has divisors other than 1 in itself. Are you starting to see the picture now? Then, how about 5? 5 has no divisible numbers other than 1 and 5. Therefore, 5 is a prime number. So a prime number is a number that has only two divisors, 1 in itself. Having two divisors is the key point. For example, 1 is not a prime number because 1 is divisible by 1, and also divisible by itself. But since 1 is 1, there is only one divisor, which is 1. A number is a prime number if it has two different divisors. Remember this point. 1 is not a prime number. Now, let's think together about how many prime numbers there are among the numbers from 1 to 20. Let's start with the fact that 1 is not a prime number, because there is only one divisor, do you remember? Next, 2 is a prime number, and 3 is also a prime number. 4 is not a prime number because it is also divisible by 2 other than 1 in itself, so it has more than two divisors. 5 is a prime number, and 6 is not a prime number because it is also divisible by 2 other than 1 in itself. Here, you may have guessed by now that any even numbers other than 2 is not prime numbers because they can be also divided by 2 other than 1 in themselves. So, let's exclude all even numbers other than 2 from the list. That leaves us with 7, 9, 11, 13, 15, 17, and 19. 7 is a prime number because it is divisible only by 1 and 7. 9 is not a prime number because it is divisible by 3 other than 1 in itself. 11 is a prime number because it is divisible only by 1 and 11. 13 is also a prime number. 15 is not a prime number because it is also divisible by 3 and 5 other than 1 in itself. And 17 and 19 are both prime numbers. All good. Then, let's move on to prime factorization. Prime factorization is the rearrangement of a number into the form of multiplications or a product of prime numbers only. Let's take a look at what it means. For example, 15 can be translated into 3 times 5. 3 and 5 are prime numbers, which means that 15 was rearranged into the form of multiplication of prime numbers. In other words, 15 was prime factorized. Prime factorization means to express a certain number with the form of a product or multiplication of prime numbers only. Then, how about 20? When the number becomes large, it is difficult to find an answer straight away, isn't it? In such cases, just remember that you should keep dividing it by smallest prime numbers. And when you do that, it would be very easy if we use a symbol like the upside-down version of the long division algorithm to do the calculation. Watch me for a moment. 20 is an even number, so it's divisible by 2. The key is to divide the number by a smaller prime number. Then, dividing 20 by 2 get you 10, which is also divisible by 2. So, let's divide it by 2 again. 10 divided by 2 equals 5. 5 is a prime number, so we stop here. The second key point: keep dividing the number by smaller prime numbers. And when the bottom number becomes a prime number, stop there. And finally, circle all the L-shaped numbers like this. And connect all these numbers with multiplication signs. And prime factorization is completed. So, 20 equals 2 times 2 times 5. In short, 2 to the second power times 5 is the answer. Now, let's look at the exercise. If you think that you can answer these questions yourself, feel free to stop this video and try it yourself first. If you are not so sure, then let's continue to look at this together. Question number 1. Prime factorization of 28. Prime factorization means to express a certain number with the form of a product or multiplication of prime numbers only. How do we do this? All you need to do is to keep dividing the number with smaller prime numbers until the bottom number becomes a prime number. Circle all the L-shaped numbers and connect them with multiplication signs. Now you remember. Okay, let's factorize 28 into a product of prime numbers. 28 is an even number, so let's divide 28 by 2, which will get you 14. Which is also divisible by 2. So, let's divide it by 2 again. Then you get 7. 7 is a prime number, so we stop here. And what do we do next? Circle all the L-shaped numbers like this, and connect all these numbers with multiplication signs. So, 28 equals 2 times 2 times 7, in short, 2 to the second power times 7 is the answer. Question number 2. 90. As in the previous question, let's continue dividing it by smaller prime numbers until we reach the prime number at the bottom. First, 90 is an even number, so it is divisible by 2. 90 divided by 2 get you 45. Next, what can divide 45? 45 can be divided by 3 or 5. How do we know whether a certain number can be divided by 3 or 5? There is a very useful method to find out whether the number is divisible by 3 or 5. A number is divisible by 3 if the sum of its digits is divisible by 3. For example, 531. It's hard to tell at a glance, but when you add up all the digits, you get 5 plus 3 plus 1 equals 9. And 9 is a multiple of 3, so 531 can be divided by 3. Same as 45. 4 plus 5 equals 9. And 9 is divisible by 3. So you can divide 45 by 3. And a number is divisible by 5 if it ends in 5 or 0. 45 ends in 5. And therefore, we know that 45 is divisible by 5. This method of determining whether a number is divisible by 3 or 5 is very useful, so if you did not know this, please remember it. Let's get back to the question. 45 can be divided by 3, so we get 15. 15 can be divided by 3 again, so let's do that. And then, we get 5. 5 is a prime number, so we stop here. Next, circle all the L-shaped numbers like this. And connect all these numbers with multiplication signs. Then, we get 2 times 3 times 3 times 5. In short, 90 equals 2 times 3 to the second power times 5 is the answer. Question number 3. How about factorizing 560 into prime numbers? That's easy, too. Do you reckon? Just keep dividing it by smaller prime numbers. 560 is an even number, so it is divisible by 2. 560 divided by 2 get you 280. Again, 280 can be divided by 2, which will be 140. Again, divide it by 2, and you get 70. Repeat the same procedure. Divide 70 again by 2. Then you get 35. 35 is an odd number, so you cannot divide it by 2 anymore. What can divide 35? Remember, a number is divisible by 5 if it ends in 5 or 0. 35 ends in 5. And therefore, we know that 35 is divisible by 5. So, let's divide it by 5. And you get 7. 7 is a prime number, so we stop here. Next, circle all the L-shaped numbers like this. And connect all these numbers with multiplication signs. Then, we get 2 times 2 times 2 times 2 times 5 times 7. In short, 560 equals 2 to the 4th power times 5 times 7 is the answer. Okay, let's look at the last question. Question number 4. This is an extended question, but it's a very well-known question, and you'll often see it on the SAT exam or selective school tests and so on, so by all means, let's learn it. Question number 4. We want to multiply 18 by a smallest possible natural number, so that the result will be the square of a certain natural number. What natural number should we multiply 18 by? I'll explain how to do it. The key to this question is to first prime factorize 18 to understand what kind of numbers 18 is made up of in the first place. Since 18 is an even number, it is divisible by 2. So you get 9. 9 is divisible by 3, so divide 9 by 3. Then you get 3. 3 is a prime number, so stop here. Then we know that 18 is made up of 2 times 3 times 3, right? And the question says we want to multiply this by the smallest natural number to get the square of some number. Here, the square means the same number times the same number. So if we can create a pair of same numbers, that would be the answer. Let's look at it. We already have a pair of 3, but we don't have a pair for the number 2. In order to create a pair of the same number, if we multiply them by 2, we can complete pairs and get a pair of the same numbers, like bracket 2 times 3 times bracket 2 times 3. Which means that if we multiply 18 by 2, we get 36, which is the square of 6. You got it. The point is to first prime factorize the given number and complete the pair so that they become to have a pair of same factors. So, that's it for today. Again, thank you so much for watching. In the next video, we will talk about inequalities, absolute value, and reciprocals. Please make sure to watch that video too. Also, if you like this video, please don't forget to subscribe my YouTube channel for the easiest math tutorials on planet.